Alright, so some examples of linear equations would be things like 2x plus 3 equals y. You might see something like 2x minus 4y equals 8. So what we're looking for is only add or subtract is involved, or a multiplication, like 2 times x or 4 times y. And you notice that all of these exponents understood to have a 1. So some things that are not linear would be things like 1 over x, or if you had something like y equals 2x cubed, because our exponent is not a 1, it's a 3. Linear function is a function whose ordered pairs will satisfy an equation, which means that it'll make it work. It can be rewritten in the form y equals mx plus b, which should look familiar. M is slope, and b is y-intercept. And we'll talk about those more in depth in just a moment. Is it a linear function? So here's some more examples. This is yes. Only adding, subtracting involved, or multiplication involved. Second one is no. Why? Because there's a 3 there as an exponent. Last one is yes. Wait. Evaluate does not mean to solve. If we solve, then our answer looks like x equals 2 or x equals 5. But to evaluate means that we're going to substitute. So I'm going to replace my x with a negative 2. And then I'm going to do some arithmetic. So 3 times negative 2, negative 6, minus 6 is negative 12. So I just get a number when I evaluate. If I put in 0 in place of my x, we put 2 in, and what we're doing when we do evaluating, we're actually creating points that will be on this line when we go to graph it. All we're doing is making a t-chart. So negative 2, negative 12 is a point on my graph. 0, negative 6, 2, 0. When I input 2, I output 0. And so when you go to graph it, we have some points. So negative 2, and down here at 12, so 1, 8, way down here, and then 0, negative 6, so 0, 1, 2, it's right in here, 0, negative 6, and then 2, 0 will be in here, and then we can create our line because we have the equation. So all of those points will satisfy our equation. So we're finding points. That's one way that we can graph, create a t-chart. We can also graph using intercepts. So to find our y-intercept, pretend like we're starting all over again. This is a brand new problem. Realize that it is the same line that we're going to get. But to do it a little differently, we could evaluate when x is 0. So 0, negative 6. 1 and 2. And then to get the x-intercept, we let f of x or y be 0. And this time we are going to solve for our x value. So I'm going to add 6. So x is 3. So that means 3, comma 0. When x is 3, y is 0. So 3, 0 would be a point. And we can graph it. So there, again, there's our line. So there's just another way of graphing a line using intercepts. You can use slope and intercept. This is the slope. This one is the y-intercept. So what you can do is step 1 is you can plot the y-intercept point. So -6 on the y-axis. Remember which one's which. 2, 3, 4, 6. And then from this point, you're going to count up to right 1, because slope really is rise over run. So from this point, we would go up to the right 1, because we're going in, both of these numbers are positive. So up 2 in a positive direction, right 1. And we can continue to do this until we get as many points as we want to create, again, that same line. Sometimes they don't tell us what the slope is, but they give us 2 points. We want to find the slope. We have an equation. Or you can plot these points and then count. Okay, so if I'm going to plot 2, 3, 2, let me try again. 1, 2, up 3. Would be here, and then -4, -6. And if I want to know what the slope is of this line, I can just literally count rise to run. So if I start at this point and I want to count up to this point, I would count this. So we want to count up and then over. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. In a positive direction because we went up, and then to the right, which is a positive direction, 1, 2, 3, 4, 5, 6. So our slope would be 9 over 6, which does reduce. 9 and 6 are both divisible by 3. So our slope is 3/2. So you can do it graphically, or you can use these numbers and the formula. So if we do that, let's call this x1, y1. This is going to be x sub 2, y sub 2. So if I put it in the formula, y sub 2 is -6 minus 3 over -4 minus 2. Negative divided by negative is positive. We reduce. So you can notice that we got the same answer. Horizontal and vertical lines. Can we draw you a picture? So if we wanted to draw a let's say a vertical line, and 1, 2, 3, 4, let's say that's at 5. All of these points, this point right here would be 5, 1, and this point here would be 5, 2, and this point would be 5, 3, and what you'll notice is like all the x coordinates are 5s. So this is x equals 5. Its slope is undefined, because if you think about skiing down this hill or this mountain, your body would be undefinable at the bottom. We go the other way, and we draw our line horizontally this time, and we'll say that's at 5. So now this would be 1, 5. This point would be like 2, 5, 3, 5, etc., etc. So we have y equals 5. And our slope would now be 0. Because if this was a skiing thing, like a kiddie slide, bunny slide, we would have 0 difficulty. Okay, we have 3 ways, 3 forms of writing a line. Y equals mx plus b is the one that you're most familiar with. We're going to do point slope a little bit more tomorrow. But again, m still represents slope. Your x1, y1 is a point that they are giving you. And then we have standard form. Notice x and y are on the left-hand side, and it equals a constant. And we have some stipulations. A has to be positive, and all the coefficients have to be integers. So if we want to write this one in standard form, I want to get the x on the other side. So we'd have 2x plus y is 4. A is positive, and no fractions. Here A is 2, B was 1, and C is 4. All right, let's look at this one. Get the y on the other side. So we got our x and y. We kind of have the right form, but we've got 2/3 is not an integer, and A is not positive. So we need to take care of both of those things. So to get rid of, let's do the negative first. We're going to multiply by -1 to everything. So that's going to give us 2/3 x plus 2y equals 1. If you like distributing it to everybody, well, all that happens is really this, that it changes signs. All right, now to take care of this fraction, you're going to multiply by the denominator. So I'm going to multiply this whole thing by a 3. So 3 times 2/3 is 2. 3 times 2 is 6. 3 times 1 is 3. Now we're good. And I did not actually change the value of our equation, just the way that it looks. Very similar to what we do when we do fractions, like 2/4 is the same as 1/2. I changed the numbers, but it's still the same amount of pizza. You know, like if this was divided into 4 pieces and 2/4 is like that, well, it's actually 1/2. I'm doing the same thing, sort of, here. When I'm getting rid of this fraction, 2x plus 6y equals 3 is really the same line as this one. If you put this in your calculator and graph both of them, you're going to get identical lines. They're the same.